Hello, welcome to a video covering notes of tangent and cotangent parent functions. Our essential question is, what are the characteristics and formulas of the tangent and cotangent parent functions? We'll start off with a relationship of tangent with sine and cosine. Tangent of theta is equal to sine of theta divided by cosine of theta. So, knowing that information, the asymptotes for tangent of theta are going to be located at theta equals negative pi over 2 and theta equals pi over 2. And the reasoning for that is that pi over 2 and negative pi over 2, the value of the cosine of theta is 0. And remember, we can't divide by 0, so at those places we will have vertical asymptotes. You'll recall that these locations are the same as the locations for secant, because secant is 1 over cosine. Our second relationship is cotangent of theta is equal to cosine of theta divided by sine of theta. So for cotangent, our asymptotes will be located at theta equals 0 and theta equals pi. And again, these are the same as the asymptote locations for cosecant. And again, that's where sine of theta would be equal to 0, at 0 and pi. So, continuing this thought, we also have the formula for the period of tangent and cotangent, and in this case the period formula is a little bit different from sine, cosine, secant, and cosecant. Our period formula is pi divided by the absolute value of b. So the 2 is no longer present. So for the parent function, our period will be pi. Go ahead and pause, copy this section, and we'll move on. Our parent function is y equals tangent of theta. The period of tangent of theta is pi. The asymptotes are located at n times pi over 2, where n is any odd integer. Our domain is all real numbers except x is equal to n times pi over 2, so where our asymptotes are located, where n is odd. And our range is all real numbers. And if you look at the graph that I have pictured here, you'll notice that at all of the odd pi over 2 locations, we have asymptotes denoted in red. Our midline is on the x-axis. And you'll also hopefully notice that the graphs of tangent, we take the asymptotes, we cut it in half, so we're finding the midpoint between the asymptotes. And then the tangent function will rise to the right, and it will fall to the left, or you go up to the right and down to the left. So between each pair of asymptotes we have a new tangent part of the graph. And this is represented from negative 2 pi to positive 2 pi. So this is what your parent function for tangent looks like, rising to the right, falling to the left. And again, your asymptotes are located at each pi over 2 location where n is odd. So go ahead and pause this, copy down the parent function tangent information, and then we'll continue on with the cotangent. Okay, last part of our notes. This is the parent function for cotangent, so y is equal to cotangent of theta. The period is pi, again, because notice that my b number is 1, so pi divided by 1 is pi. The asymptotes are located at n times pi, where n is any integer. So you'll notice our asymptotes located, represented by the red dashed lines. We have them located at 0. We have it at pi, at 2 pi, negative pi, and negative 2 pi as part of our graph. The domain is all real numbers except x equals n times pi, so where the asymptotes are located, n being any integer. And our range is all real numbers, so this thing is always going to go up forever and down forever. And on the cotangent graph, again, you go halfway between the asymptotes, that's where you'll find a midpoint, and then the graph, you will notice, rises to the left and falls to the right. So it's basically the reciprocal of tangent. It's going the opposite direction. And over here on the side I wrote cotangent of theta up to the left, down to the right is what you need to remember about cotangent. The only time that switches is if you end up with a negative a value, in which case it will flip-flop. And the same for tangent. Let's go ahead and pause, finish copying the notes, and then we will talk about this in class tomorrow. Thank you. Have a good evening.